When talking about how the brain functions, we have to start with localization. Localization means that different parts of the brain does different things. But why is this important to know? Well, if we know what parts of the brain are responsible for speech, we can further reduce which parts of the brain are responsible for swearing. Okay, but how do we figure any of this out? Well, as Benjamin Bergen noted in What the F, a great tool for learning about different parts of the brain is aphasia. Aphasia is a neurological disorder that inhibits speech and was actually discovered quite a while ago. In the 1700s, a neuroscientist named had a stroke and was unable to speak afterward. He fully recovered and wanted to study others who had language-compromising brain damage as well, as stated by Bergen in page 70 of What the F. Lordat had come across a French priest who had also suffered a stroke, but unlike Lordat, his speech impairment was far worse. He could only say the words I and fuck, but in French, of course. Through this French priest, Lordat had discovered aphasia. To keep it simple, 3 kinds of aphasia. Broca's aphasia. They can understand the words and use them properly, but has trouble finding the words and actually saying them. Wernicke's aphasia. Allows for the ability to say words just fine, but not necessarily make sense with the words that are used and understanding them. Global aphasia. When someone is unable to speak or understand language as a whole. Neuroscientist Paul Broca had a patient named Louis Victor Leborn. Leborn had aphasia. He could only say the words tan and... After he had passed, Broca's autopsy on him showed that he had a lesion in the Broca's area located in the left frontal lobe. Not only was there a lesion there, but there was also softness of the tissue as well. As Bergen stated, aphasia is a great tool to understanding how the brain works. Broca's patient showed us that Broca's area must be heavily used when creating well thought out articulated speech. As well as it also shows that one can swear without Broca's area even being used at all. This is a fascinating discovery because it's our first bit of evidence that shows that swearing is a possible outcome even when our brain isn't 100% there. Not to mention, it's the first bit of evidence that we have that actually reduces the amount of brain that we have left to discern from when it comes to swearing. Now let's talk basal ganglia. The basal ganglia is a system of subcortical brain structures connected to the thalamus and cortex, as noted in both the Oxford Handbook of Taboo Words and Languages, section 7.3, and page 77 of What the F. One case mentioned in both What the F and the Oxford Handbook showed us this one patient who had actually suffered damage to their basal ganglia, and therefore they lost access to all their automatic speech. And of course that includes automatic swearing. Let's take a deeper look as to what the basal ganglia is actually doing. In both What the F and the Oxford Handbook, they noted of this man who was bilingual and he could speak fluently in both French and Hebrew. Both mentioned that he had damage to the right hemisphere of his brain. Because of this, he was unable to recite nursery rhymes, the singing of familiar songs, and, drumroll please, automatic speech and swearing. When looking into what part of his brain was damaged, it was noted that it was actually his right basal ganglia. As Bergen mentions, this is only one case study, so we wouldn't want to jump to any conclusions. But this case does imply that automatic speech, and therefore automatic swearing, might be linked to brain circuitry responsible for other automatic processes in the body that are closely linked to emotion centers in the brain. Along with this, we know that TS patients that have coprolalia have been seen to have dysfunctional basal ganglias as well. With these studies, we have enough evidence to assume that the basal ganglia is a key center at which expletives spawn. Lastly, let's talk about the story of a man known as Phineas Gage. Gage was a construction foreman, and one day he was putting gunpowder into the earth for some sort of explosive task. While using his tamping rod to push the gunpowder in, Gage happened to look down into the hole. And that's when it happened. The hole went boom! The rod Gage was using had gone through his skull and about 80 feet away. Miraculously, Gage had fully recovered. Physically, that is. You see, Gage, who was once an upstanding and friendly man, had now become a fairly rude, loudmouth, angry man. As his friends put it, Gage was no longer Gage. Gage's doctor, Dr. Harlow, with his finger had determined that his entire left prefrontal cortex had been destroyed. With 3D imaging software, it was determined that Dr. Harlow was actually correct and that his Broca's area was completely untouched. That's why he was able to speak and swear perfectly fine. The Oxford Handbook noted that the prefrontal cortex is the most human part of the brain. It is crucial for normal socio-emotional and executive functioning. So it makes sense as to why Gage turned into what he did after his injury, which of course led him to swear more. In this chapter of the video, we've seen how different parts of the brain can be responsible for the different ways our speech functions through various brain injuries and conditions and other sorts of things. With the basal ganglia being very important with automatic speech, and how Broca's area can be responsible for well thought out, more articulated speech, and how the prefrontal cortex can even be kind of like a picking and choosing machine for when we swear and how we swear. While individual brain regions are key and helpful to understanding the basics of what goes on up here, knowing how each part in a system works with one another and then how those systems interact with one another will provide us with a lot more information than just the base parts. This idea that the brain is a network of networks has been around for a long time, even back when localization was becoming popular. Even by some localizers that we read about in the last chapter. Understanding how these networks connect is the first step to understanding this idea as a whole. Our brain is made up of these things called neurons. The neuron's electrical signals travel along the path known as the axon. The axon, connected to the nucleus and cell body, acts as a pathway for the signal to reach the other side of the neuron with the synaptic terminals. When the terminals reach their potential, they build up enough energy to cross what is known as the synaptic gap, connecting to the next neuron. Brain region pathways are often studied via animals using radioactive dyes. Directly human studies had to wait for new and different technologies to arise, and because of that, many of the hypotheses talking about human brain function stem from these animal studies. Stated directly from the Oxford Handbook, diffusion tensor imaging, DTI, is a magnetic resonance technique that traces white matter by measuring the diffusion of water in the neuronal tract. Functional connectivity MRI, fcMRI, is another approach based on temporal synchrony in the activity among regions. Regions that activate together in fMRI scanning, that their hemodynamic activity is coupled, are considered functionally connected, whether their coupling is during performance of a task or when an individual is at rest. Unlike DTI, fcMRI does not identify the connected anatomy, it defines functional connectivity. Put simply, fcMRI defines which regions work together, connected or not, whereas DTI defines which regions are physically connected. While localization helped us understand the basics of how the brain works, networks allow us to see things in a much bigger picture. Damage to networks can open up the concept of aphasia and other disorders. By comparing symptoms and disorders with the affected network, we can see if it's the network that matters or the actual anatomy within the network. The limbic system is an earlier developed part of our brain that is a central factory to where our emotions are produced. The limbic system houses many brain structures connected by many pathways and circuits that are key to emotions. Both Bergen and the Oxford Handbook mention patients with Tourette syndrome and coprolalia. Bergen mentions this because of the damaged basal ganglia and coprolaliacs. It is unable to suppress the verbal impulses brought on by the limbic system. As well, he also stated that when the limbic system of squirrel monkeys are stimulated, they produce emotional vocalizations. But, as Bergen mentions, the caveat to this is that our expletives are learned and socially driven. That's different from the natural growls and other noises that animals like that would make. The Oxford Handbook mentions 2 studies that sheds light on a few limbic system structures involved with coprolalia. The first study focuses on a participant in a PET imaging study. 90% of the participants' tics were vocal. When scanned, many of his tics showed activation of the temporal lobe, which is implicated in speech processing. Coprolalia-related activation was seen in the basal ganglia, insula, thalamus, and cerebellum. The second study is of a 15-year-old boy who says fuck on an average of about every 2 seconds or so. After being compared to a healthy girl his age, it was found that only he showed activation to similar areas as the person in the last study. These studies reinforce an idea from Chapter 1 that the prefrontal cortex and basal ganglia are key to swearing. As you may know, a circuit is a loop, a system that always comes back to its origin. The brain is full of circuits, and many of these are important to us when it comes to swearing. While there are tons of circuits in the brain, today we'll be focusing on the CSTC ones, specifically the limbic and the prefrontal ones. Deep brain stimulations, or DBS for short, is used on patients when behavioral or pharmacological therapies are not really working on them. Electrodes are put on a specific part of the person's brain and then activated. Through this, we can see what circuits are linked to what kind of behavior through the recorded responses. 2 patients suffering different kinds of copra phenomena had underwent this. They had put electrodes on their globus pallidus and had seen astounding results. Many other patients who underwent DBS saw symptoms improve, if not go away completely. While the different parts of the brain in the DBS tests varied, we do know that they took place in either the limbic or the prefrontal CSTC circuits. In this chapter, we've seen how grouping parts together and viewing them as a system can play important roles. Specifically in the DBS part, where Tourette's patients were treated or even cured. The electrodes being in different spots showed the importance of systems, that they can be anywhere and still cause the same effect. In the first page of What the F, Bergen says, "And the most potent words of all, the ones that have a direct line to emotions, are profanity." You know it, I know it, we all know it. We swear when we're happy, we swear when we're sad, we swear when we're angry, we swear as just a general form of expression. In section 7.6 of the Oxford Handbook, emotions have two characteristics, valence and arousal. They can be represented as a vector on a graph. Valence is how pleasant or unpleasant the experience was. Arousal is how intense the experience was. This is all in response to stimuli experienced by the person. As you can see, this vector on the graph represents a mildly intense, pleasant emotion. There is also another way to think of emotions, that there are 6 innate emotions: anger, fear, sadness, disgust, happiness, and surprise. The handbook states that these proposed models are not exclusive, rather they are just different perspectives of emotion. Burns says that emotion is an essential part of our mental processing, and losing it can be cognitively disastrous. And later on in that page, she says that she agrees with the hypothesis that swearing is actually a very specialized and emotionally fluent form of language that requires us to have a mental model of the emotions, not just of ourselves, but also the person who hears us swearing. And I couldn't agree more. I don't swear when I'm in professional settings or when I'm with family. Rather, I keep it in when I'm in a more relaxed setting, like alone or with friends. This is the amygdala. You have one on both sides of the brain. It's small but powerful. The amygdala is found in just about every mammal, and most other kinds of animals have something similar as well. The amygdala size is a great indicator on if you'll have depression or even if you'll have longer-lasting friendships. Essentially, the amygdala is a relay in our brain that lets us know what emotions we should be feeling. And there have been live tests done on the amygdala. Burns talks about one on page 27 of Swearing is Good for You. 2 doctors were doing an open and live brain surgery. The doctors asked him how he was doing, and he responded with, "Okay." Then they started artificially stimulating his amygdala with an electrode. They then asked the man how he was feeling, and he responded with, quote, "I can hardly speak, bleep. I just want to get the bleep out of here." Byrne notes that the swearing wasn't recorded, unfortunately. As Byrne notes, the important thing here is that he swore when he was being stimulated. Because of this, it's thought that the amygdala plays a larger part in suppressing unwanted swearing, and there's probably a larger system here at play. Once again, Byrne notes that the removal of the amygdala reduces emotional responses, especially in aggression. Back to the Oxford Handbook. When anger's arousal is high, it becomes rage, and with rage comes its expression. Aggression can stem from rage, but it can also stem from sexual competition or other competitive endeavors. But it doesn't have to. People with Tourette syndrome often have rage attacks, moments where they get very irritable and they have outbursts and even get physically violent. Swearing is likely most prevalent in anger. Broca even linked LeBorn swearing to anger. And if you forgot, Alzheimer's said Johann would swear when teased. The Oxford Handbook mentions that a key structure in anger is the orbital medial region of the prefrontal cortex, and when lesioned, anger is likely to show. Once again bringing that humane part of the prefrontal cortex to life. They listed a few other parts as well, but primarily one being the amygdala, which we already talked about. The Oxford Handbook also says that Hewlings-Jackson was okay with swearing and that he even invited it as it reduced physical aggression, of which I would have to agree. When I was in high school, Coach had a no swearing policy. I would get so emotional on the sidelines. When Coach wasn't around, I would scream, swear, do all that sort of stuff. But when he was there, I would just have to hit myself in the chest, take my helmet off, bash that against the ground, stomp on the ground. It is known that men are typically the more aggressive of the genders. Testosterone is the main culprit of this. Men tend to have about 4 to 8 times the amount of testosterone that women do. But do men swear more than women? Well, let's talk about the social implications of what happens when men swear versus women. Society started painting women as a pure angel rather than something more sinister like they used to be. Because of this shift, swearing from women started to be seen as something as impure or something that God hates. Because of this, and what we know about swearing and emotions already, this allowed for men to take a sort of upper hand and exude more power in social situations and be viewed less tabooly. Over time, you saw how gender-directed swearing became more sexual. Not sexual in the sense of sexy, but more in the sense of degradation or bullying. Swears toward men tend to be more questioning sexuality, like calling one the F slur or calling them a girl. Whereas toward women, it seems to be more like sexual inconsistency, with words like slut and whore and so on. Along with this, it's noted by Byrne that the similar genders actually tend to swear more toward each other than their counterpart. Because of this, it's recorded that women only take approximately a third of the verbal profane blows. Earlier we mentioned that Byrne noted that swearing is almost its own language. It has its own emotional and social intricacies. She went more in depth on that, noting that women tend to use swearing more to add punch or get the attention of someone. On the opposite end of that, she notes that men use it as a form of banter in a jocular way, or even as a way to maintain good morale at work. She also mentions that men can use it as a sort of way to hide their vulnerabilities when they're in moments of intense social pressure. Nowadays, it's recorded that women are responsible for up to 45% of all public swearing, which is up from 33% in 1986. So while it may be true that men swear more than women, that gap is certainly closing and may even get overtaken. Dr. Richard Stevens of Keele University held a study and managed to get 67 of his students to participate. The study was simple. You gotta put your hand in ice water and hold it there for as long as you can. Twice. The first time, you were only allowed to say a neutral word, such as chair, and the second time, you got to say a swear word, such as fuck. The idea is that if swearing holds as much power as it seems to, the students will be able to last longer in the ice when swearing. The results of the experiment said it all. Swearing helps with pain. Byrne notes that pain used to be thought of as purely biological, but as we now know it, we know it's very psychological in many different aspects. In fact, many different psychological phenomena can interfere with how painful something is, like sexual reasons or even past experiences. Another study looking at this was Claire Alsop's, a student of Stevens actually. The study was designed to build someone's pain tolerance by getting them angrier. She had her fellow undergrads play either a shooting game or a golf game. She then prompted her peers with fill in the blanks to gauge their aggressiveness. After that, she did the same ice water experiment as Dr. Richard Stevens. These were the results for the calmer students. On average, men could hold them in there for 117 seconds and women for 106. These were the results for the more aggressive students. On average, men could hold it in there for around 195 seconds and women for 174 seconds. This shows that aggressiveness can possibly be perceived as a painkiller. Byrne talks about another experiment gauging people's natural aggression levels and their pain tolerances. And it was shown that the more aggressive people could typically handle more pain than the less aggressive. We've talked about physical pain so much, but what about social pain? To start, Byrne notes that both marijuana and acetaminophen have been seen to reduce social pain just like they do physical pain. We know that when we experience extreme physical trauma, it heightens our pain tolerance because fighting or fleeing isn't an option. It's an evolutionary survival tactic. An experiment was done to see if severe social pain can also heighten our physical pain tolerance. To spare you the heartbreaking details, the patients who did feel the severe social pain did have heightened pain tolerances. The Oxford Handbook notes that the limbic system plays a part in both physical and social pain, specifically with the social pain when it comes with severe loss or rejection. We learned a lot in this chapter, primarily that heightened senses of anger and aggression can act as a painkiller. We also learned that social and physical pain work in similar, if not the exact same ways.